Good morning, students. Today also we can have a discussion on the chapter heat. Now, first we are comparing the term heat and the term temperature. The first few points we have already learned. Heat is a form of energy and having the ability to do work. So any form of energy having the capacity to do work or ability to do work, whereas temperature is the degree of hotness or coldness. Heat is a cause, whereas temperature is an effect. So these are the points we have already discussed. SI unit of heat is joule. Here the SI unit of temperature is Kelvin. Now these are the few points that we have to add today. Two bodies of same substances having different masses may have same amount of heat but different temperature. One more time, for example, I'm having water. So different masses. In one hand I am having 1 kilogram of water. In the other hand I am having 2 kilogram of water. Okay. Now having different masses may have same amount of heat. These two, this 1 kilogram water and 2 kilogram water may contain same amount of heat but different temperature. For example, if it is 30 degrees Celsius, then it would be 15 degrees Celsius. This is 1 kilogram of water. This one is 2 kilogram of water. Both are same substances having different mass, but it may have same heat. If it is having same heat, same amount of heat, then the temperature will be different. Since here it is 2 kilogram water and here it is 1 kilogram of water, its temperature, the 1 kilogram of water may have higher temperature, this may have lower temperature, so the temperature is different, but it may have same amount of heat. Here two bodies of same substances, just like 1 kilogram of water and 2 kilogram of water having different masses, may have same temperature but different amount of heat. 1 kilogram of water and 2 kilogram of water both having 30 degrees Celsius. Since its mass is higher, its amount of heat will be also higher. So the different amount of heat, if it is having same temperature of same substance but different masses, then the temperature will be if the temperature is same, then the amount of heat will be different. The amount of heat will be different. For example, 1 kilogram of water and 2 kilogram of water having 50 degrees Celsius, then the amount of heat contained in these two bodies will be different. It will be having, since the mass is higher here, it will be having a higher amount of heat than this 1 kilogram of water. That is the minimum. Now heat contents of a body do not decide the direction of heat flow. Heat contents of a body do not decides the direction of heat flow. Even if the heat is higher in a body, we can't predict the flow of heat. For example, here I am having 1 kilogram of water. Here I am having 10 kilogram of water. Okay. Now here the 10 kilogram of water is in 50 degrees Celsius. Okay. The 10 kilogram of water is in 50 degrees Celsius. Whereas in 1 kilogram of water is 49 degrees Celsius. This is 49 degree. This is 50 degree. If you are mixing it, from where to where the heat flows? The heat flows from 50 degree to 49 degree. body. Here it is 50 degree, here it is 49 degree. Here this one is 1 kilogram of water, this one is 10 kilogram of water. So heat flows is from 1 kilogram of water to 10 kilogram of water since the temperature is higher here. But if you are looking at the amount of heat, since the mass is very high compared to this one and the temperature difference is a bit, the temperature difference is very low, it will be having higher amount of heat. The amount of heat will be higher in 10 kilogram of mass of water which is at 49 degrees Celsius, but here the amount of heat will be low, but heat flow is from 1 kilogram of body to 10 kilogram of body. So the amount of heat cannot predict the direction of flow of heat, but the temperature of the body decides the direction of flow. Since it is 50 degree Celsius and it is 49 degree Celsius, heat flows from 50 to 49, higher to lower. The heat always flow higher to lower. Wherever the temperature is higher, from that body to the lower temperature, the heat flows. From hot body to cold body, the heat flows. Now thermometer. The word thermometer is actually combination of two Latin words, therm and meter. Here the thermal energy or therm is related with the term is related with heat and meter is related with measurement. So thermometer is the device which measures the temperature. Thermometer is the device which measures the temperature. So we are the one kind of device is mercury thermometer. We will be having a tube and in the lower side we will be having a bulb that is a metallic conductor, and inside we will be having a thin film of a thin tube of mercury column. So that is the construction of the mercury thermometer. Why we are using mercury thermometer? Why we can't use water thermometer? So mercury having particular advantages or characteristics. Mercury having certain advantages and characteristics. That's why we are making use of mercury. So some of the characteristics I have written here: expands evenly. Evenly meaning uniformly. For example, from 30 degree to 31 degree, the expansion will be same as the 40 degree to 41 degree. So it expands uniformly. When heat increases, the expansion will increase uniformly, not in a uneven manner. For example, we are considering from 30 to 35 degrees Celsius, the thermometer increases, the level increases by 1 centimeter. We are just assuming. Then from 50 to 55 also it will be, the increase will be 1 centimeter. So that is why it is called evenly or uniformly. Now good conductor. Though mercury is a liquid, it is a conductor. So it is a good conductor. High density. Mercury having high density. How we are making use of the high density of mercury we will learn later. So one thing you can understand, that mercury having high density, that peculiarity also we are using in it. Sensitive in expansion. For example, for small amount of heat, if you are giving a small amount of heat, for the respective increase in the level of the mercury column will be there. For a small amount of fall of heat, that is if the temperature is fallen a bit low, then those reading will be accurate in the mercury if you are using mercury. So sensitive in expansion, the thermal expansion will be very sensitive in the case of mercury. Does not stick on the wall of the glass tube. Even if we are taking the mercury in our hand, the the hand will not be get wet due to mercury as we are touching the water. If you are touching the water, the hand will be getting wet. Whereas if you are taking the mercury even in our own hand or even in the paper, actually mercury is a toxic substance, so we can say if you are taking the mercury in a paper, the paper will not be get wet by the mercury, and that is a particular kind of force which you will learn in chemistry, that is adhesive force and cohesive force, that is actually out of our discussion. Now, low freezing point and high melting point. So for example, the water freezes at 0 degrees Celsius and boils at 100 degrees Celsius, whereas mercury will not be melt easily or it will not be boiled easily. So high melting point and high boiling point, these are the characteristics of mercury. Now moving on to yesterday's question, yesterday's discussion. This is the equation for, I'm revising whatever we have learned yesterday. Now see, this is the equation to use to convert degree Celsius to Fahrenheit. Degree Celsius to Fahrenheit. If we are provided degree Celsius and if we are asked to find Fahrenheit, this equation should be used. What is the equation? Degree Fahrenheit equal to 9 by 5 into Celsius, degree Celsius plus 32. So this is the equation to convert Celsius to Fahrenheit. Celsius to Fahrenheit. Celsius to Fahrenheit. What is the equation? Degree Fahrenheit is equal to 9 by 5 C plus 32. Whereas Fahrenheit to Celsius, this is degree Celsius equal to 5 by 9. Here we are telling 9 by 5. Here we are telling 5 by 9. Bracket. Here the bracket is compulsory. If you are not putting the bracket, you will make mistake, because it is there is a mathematical procedure or priority while doing a calculation, that is board mass or bed mass. We will say bracket, then after the bracket only the multiplication or expansion will come. Now sorry, after the bracket or expansion only the multiplication will come. Now 5 by 9 into degree Fahrenheit minus 32. This is the equation to use to convert Fahrenheit to Celsius. Now lower fixed point. L stands for lower fixed point. For example, if you are taking Celsius scale, the lower fixed point is actually, we told yesterday, the freezing point of or melting point of ice or melting point of water. Though the ice melts at 0 degree Celsius. So the melting point of ice is the lower fixed point in the case of degree centigrade or degree Celsius, or even in the case of Fahrenheit also, the melting point of ice is the lower fixed point. Melting point of ice is the lower fixed point in degree Celsius as well as Fahrenheit, but their numericals are different. In the case of degree Celsius, the numerical stand for the melting point of ice is 0 degree Celsius. In the case of Fahrenheit, the numerical is 32 degree Fahrenheit. So 32 degree Fahrenheit stands for melting point of ice. 0 degree Celsius also stands for melting point of ice. So the 0 degree Celsius is equivalent to 32 degree Fahrenheit. Similarly, the boiling point of water is taken as the upper fixed point in both scales, Fahrenheit as well as Celsius degree. Now upper fixed point UFP, that is taken as the boiling point, is taken as the upper fixed point. So boiling point of water in degree Celsius is 100 degrees Celsius, whereas in Fahrenheit scale it is 212 degree Fahrenheit. So 212 degree Fahrenheit it represents, yeah, 212 degree Fahrenheit represents the boiling point of water. 100 degrees Celsius also represent boiling point of water. So 100 degrees Celsius is equivalent to 212 degree Fahrenheit. Now boiling point, melting point, this MP is nothing but a melting point, BP is nothing but a boiling point. It is also called a steam point, boiling point or steam point, normal atmospheric pressure. So the melting point is taken as 0 degree Celsius in normal atmospheric pressure. That is, the atmospheric pressure varies with weather. So when weather varies, the atmospheric pressure varies. Okay, so we will consider a normal atmospheric pressure. That those detail we can discuss later. So now we can discuss one few questions related with the conversion. This one is actually not good. I can take this one. Now listen, convert, question number 1, convert minus 40 degree Fahrenheit to degree Celsius. So Fahrenheit is given, what is asked, degree Celsius is asked. So we have to convert into Celsius. So which equation? This one or this one? This one should be used. Fahrenheit is given. Now we are asked to find degree Celsius. So we are trying to find it. Now listen. Degree Celsius is equal to our, what is our equation? 5, yeah, 5 by 9 into F minus 32. F minus 32. So we are just trying to find it. 5 by 9 into F is, what is F? Minus 40 degree minus 32 degree. So here degree I am using, I am omitting it. So minus 40 minus 32. So that is 5 by 9 into minus 40 minus 32 is nothing but 40 plus 30, that is 70. So minus 40 minus 32 minus 72. So minus 72. See, now we can write it as 5 by 9 into minus 72. How many times 72 goes? How many times 9 goes in 72? That is 8 times. So we can write 5 into minus 8. That is nothing but minus 40 degree Celsius. So here we are if we are telling this as minus 40 degree Celsius. Oh, here there is a communication, generalization. So let it be there. Here from here onwards we can write it. Minus 40 degree Fahrenheit is equivalent to minus 40 degrees Fahrenheit is equivalent to minus 40 degree Celsius. So this particular value, this particular numerical minus 40 is same as here also minus 40. So whenever we are getting minus 40 degree, the numericals of Fahrenheit and the numerical of degree Celsius become equal if the temperature is minus 40. So minus 40 degree Fahrenheit is same as minus 40 degree Celsius. Okay. For example, if you are converting, now we can try to convert Celsius to Fahrenheit. For example, we can try to convert our own body temperature. Our own body temperature can be tried. So, for example, convert 37 degree Celsius to degree Fahrenheit. So, what is asked? What Fahrenheit is asked? What is given? Degree Celsius is given. So, degree Celsius is given. Fahrenheit is asked. So, Fahrenheit equal to, we can start from degree Fahrenheit equal to 9 by 5 into degree Celsius plus 32. Okay, so 9 by 5 into degree Celsius. What is a degree Celsius? That is convert 37 degree Celsius to degree Fahrenheit. Okay, so degree Celsius is 37 plus 32. So 37 divided by 5. 37 divided by 5. In 35, how many times it will go? It will go 7 times, right? 7 into 5. 75 is 35. So we can write 35. Now remaining is 2. Into 5 will not go, so we will put the decimal. So here we can write 20. In 20 it will go how many times? 4 times. So 37 divided by 5 is nothing but we can write it as 7.4. So 9 into 7.4 plus 32. So 9 fours are 36. Remaining 3 is the 9 into 7. 7 nines are 7 tens are 70. So 7 nines are 63. So here 63, here it is 3. So 66.6 plus 32, that is 2 plus 6. 2 plus 6 is 8. 3 plus 6 is 9. So 98.6. So 98.6 degree Fahrenheit is equal to our 37 degree Celsius. So 37 degree Celsius is equal to 37 degree Celsius is equal to 98.6 degree Fahrenheit. So if you are asked to find your body temperature in Fahrenheit, you can say your body temperature, the average body temperature is 98.6 degree Fahrenheit. So there will be questions in order to convert from Fahrenheit to Celsius or Celsius to Fahrenheit. Now I hope you can have the calculation. Thank you.